Yeah, so just like that, AWS has hundreds of services, but most important the one which is like EC2, storage and all kind of things, same way. So here we have a namespace, pod, deployment, and services. Now, what is a namespace? Before namespace, I'm going to talk about some of the commands which you should run. So if you see that this is my workstation, and it's to set up the clusters with the Rancher desktop, which is in my laptop only. Okay, so Rancher desktop is using WSL for setting up this cluster. So can we run this now? So if you see that here, command is kubectl. Okay, you have to work on this kubectl, and these are the commands which you have to learn actually as part of this. So I want to know how many configurations for the clusters. So if you see that config uh, kubectl config view, see this is my cluster. Look at this, my cluster is running at this particular WSL, means this particular IP address, and then 6443. That's IP. I mean, this one. What is it? Just if config. Yeah. So this is my IP address for machine, but this is running in the WSL machines. And the port number for this is the API address. Okay, this is the API address, and some of the more informations you have here. So this is my cluster detail. Now I want to know my cluster is healthy or not. So what command I will run? So there's one command which is called clustered info. Do you see somewhere? Clustered info. Here it is. So this is the command we should run to check the health, whether the cluster is okay or not. So kubectl cluster info, and here it is. And now you see that cluster is up and running, healthy, no problem. Now I want to know how many nodes you have for this. kubectl get pods, sorry, nodes, get nodes. This is the command to get the nodes. See here. So right now I have only one node. Remember that there's one node which is acting like a master also and workstation also. Kubernetes version is 2.1.29, which is the most recent one actually. Okay. So this is something which we have. Now what else you want to know? So now if you see that kubectl get ns, here these are the one, two, three, four NS you have. NS means namespace. So four namespace we have, but the question is what is a namespace? We need to understand. By the way, guys, let me tell you here. The typically I like you to practice everything on the command line. Okay, that's the reason I'm running it. But because we have already installed the Rancher desktop, you can also check it out UI for it. But you should not get addicted to UI command line. You are a DevOps engineer, SR engineer. You should be fond of command line, not UI. UI is a part of management or non-technical person. So if you see that here, this is the one cluster, local cluster, and how many namespace we have? Look at this one, two, three, four. How many nodes we have? One node. How many events has happened so far in the cluster? These are the one. Workload I have not created it, so these are the workload right now. By the way, I see that pods, stateful set, and all these all coming 000. So their system pod is running, but right now it's not been shown. So user pods are nothing. Service discovery, here you have. Storage, here you have. Policies, here you have. So all this thing you can view through, yeah, I mean through UI also. That's one of the advantage what you have for the this one, Rancher desktop. Got it, all of you? Any questions? Any questions? Hello.
No, Raj.
Okay. So now what? The first thing which you want to learn that is in Kubernetes, and that's called namespace. What is a namespace? So guys, I'll simplify this one. So here, this is the cluster. Okay. Think about it. And this cluster is powered by multiple worker, one worker, two worker, and three worker. Now understand that when we have a three worker or 3,000 worker, this is considered to be one cluster. Okay, that is a logical view for it. So one cluster. If you say 10 GB RAM here, 10 GB RAM here, 10 GB RAM here, that means you can say my cluster size is 30 GB. something like this. Okay, so now see here, there's a team one. Understand this, there's a team one, there is a team one, and there is a team B, team A and team B. Now you know what? Team A project, they deploy the pods. Pod is a compute unit where the containers is there. Okay, and then this guy also deploy the pod. Okay, now technically these pods will be running in this one and here. This pod will be running here and here. This pod will be running here and here. Now the problem is these two different individual which you see is a different project, and each projects are using the each projects are using the what do you say uh, their own worker for the running the I mean same cluster but different worker, but it's not, it's a shared worker actually here. Okay, so what is happening here? Just imagine, think about it. Let's say this pod which has a container, and container has certain bugs and which is consuming most of the CPU and RAM. What will happen in that case? What will happen? So in that case, what will happen? This is using this machine, this is overoccupied, overconsumed. So now you have a downtime for this blue one. Are you understanding? So what I'm trying to say here, what I'm trying to say here what I'm trying to say here is, when you have when you have cluster, then you are supposed to share with multiple projects, multiple product, multiple division. Cluster is only one for the entire organization. Now, because we have multiple services, multiple product, multiple teams, everyone asks for that. Hey, I need this resources, I need that resources, whatever it is. They fight for the resources. When I say resources, means compute unit, storage unit, and so on. So now the question is, how should we divide the clusters, different segments? How can we do that? And that is where namespace concept is coming. So what Kubernetes is saying, hey, listen, do one thing. We cannot divide the cluster like this, vertical division, because it will become a separate cluster. In that case, I have to have only one cluster, but logically divide this. So divide into two part or 10 parts. Okay, and this is assigned to someone, this is assigned to someone, and you set the limitation. Let's say you cannot use more than 5 GB, you cannot use more than 10 GB, and something like that. So this logical division of the cluster, what you see here, is called namespace. Okay, so that means now if you see that every pods you can run in the namespace. So here these are the namespace you have: queue system, queue public, node, and default. So right now, if you create any pod, it will go to the default, but you can create a new namespace also. Now this namespace is important. Okay, so this namespace where the Kubernetes is running their own pod, which is for the masters. Master control plane requires multiple software, right? These softwares are nothing but running in the namespace only. This one in the pods only. This is running in the pods only. So let me show you those pods. Okay, so now queue seat here. See here, when I did get pods, see here, nothing is there. But which namespace it is querying? Default namespace, mind it. Okay, so it's querying the default namespace. But actually, I was looking for the pods in the cube system namespace. So what I'll have to do, -n is equal to cube system namespace. And you see, these are the pods. Now, can you tell me these pods? Can you resemble that here? These are the pods, which is the system pods actually. Okay, all of you clear now? Hello? Okay, so now what we are going to do, we are going to create, I mean, see, these are the things we are going to create. So for that, we are going to follow the formula. Which formula? So CRUD formula. So create, read, update, and delete. So create namespace, read up namespace, update namespace, delete namespace. Create a pod, read a pod, update the pod, delete the pod, create a deployment, read the deployment, update the deployment, and so on. So first of all, you understood the namespace now. So let me do one thing. Let me create a namespace first. So I am using the command line to create namespace. So qctl create shortcut ns and the name of the namespace Rajesh. See here. So get now reading get ns. See here Rajesh created. Now create read done. I want to edit this namespace. So edit ns Rajesh. I'm editing the namespace. It will open up one command, I mean notepad or something like that. I think it opened up already somewhere. No, I don't see. Uh, edit one more time. Edited is not set, I guess. Export editor is equal to VI. Edit unable to launch the. Oh, VI editor is not there in this, no, guys. So, oh, is there already there? What should I do? That is a problem. VI editor is there, but it's not opening. Uh, or is it open? No, it's not open. Okay, so let's do one thing. Our workaround. Let's modify through UI. So go to here, go to the cluster namespace Rajesh, and here you see the config. Okay, and edit YAML. Okay, and here I want to modify live. So what to do? I'm going to add one more label. This is a team DevOps school. Okay, and save it. Done. Modify. Now I want to see the through command line qctl. Okay, describe namespace Rajesh. See that here? Labels got added. And finally, you want to delete it. CRUD means last one. You want to delete it. So qctl get ns qctl delete. You can do all this through UI also, but I don't want you to practice it. Okay, here Rajesh. So this is something you have to do if you really want to create a namespace. Then oh, see here, actually it was open actually. Where is opening? Uh, Not here. Where is that? It's here. It got open. I was wondering why it's not opening. Yeah, two times it got open. Okay, so now did you understand that all of you how do we work with the namespace and how do we create, read, update, and delete? All of you? Hello? Hello, Patrick?
Yes, Rajesh.
Yeah. Okay. So now next thing is I am going to create a pod. But before that, I need to understand what is a pod. So pod, what is a pod? So basically, pod is having the containers. Okay, understand that. Pod is having containers. Now pod is instantiated by kubelet. Understand? And you can have multiple containers. So if you look at this, this is a good image for this. Quality is not there, but that's okay. If you see that pod, you may have one container. Pod, you may have a two container. Pod, you may have a multiple containers as well. Okay. Pod, each pod you have IP address. Okay, you see that 10 dot data. And pod, you can attach the volumes. Okay, so container which has an app and the volume which has a storage. For example, I'll tell you in a simple way. When you go to the AWS, you create a VMs, right? And the VMs you attach to the EBS volumes. So same way, pod you can attach to the volumes for storage, persistent storage. Okay, so this is one of the simple image, but again, if you look at this here, I think this is a more clearer, and so on. This is also, you see that same thing. So now how can we create a pod? So guys, there are so many resources are available in the Kubernetes to create a pod. Which are those? So let me show you. So kubectl API resources. That means this will give you all the feature of Kubernetes, all the feature of Kubernetes. Okay. Now, if you see that these are the features you have to learn over the period of time, but there's so many ways to set up a pod. So many ways. Now, one of the easiest way to set up a pod is kind equal to pod itself. Another way, you can set up a create a pod using replication controller. Okay, you can set up a pod using replica sets. You can set up a pod using deployment. You can set up a pod using stateful set. Stateful set. You can set up a pod using daemon. You can set up a pod using jobs. You can set up a pod using cron jobs. So guys, these are the ways you can get the pods. All these has a pods way to get a pods itself. But the question is, you need to understand the difference between each of these. So in this session, I'll talk about the pods, this one, the one which you get one pod, and here I'll talk about the deployment. Using that, you can get a hell lot of pods. Okay, but all others also you have to learn slowly. These two are important to get started with. So now the question is, how do we get a pod? So guys, I need a YAML file for that. Last time I showed you the command, now YAML file. So Kubernetes pod example DevOps school. Okay, now this is a static pod, not this is the one. You can refer this one. So look at this, guys. This is the pod specifications. Okay, so I'm creating a pod. So here, what do you want? Kind is equal to pod. What is the name of the pod? So I'm going to name the pod of the Rajesh. And what is the labeled with? This one. Pod will come have a containers, right? What is the container? So this is my image which I uploaded few years before. I think 5-6 years before. I'm continuing using that. And the pod, this is nothing but Nginx. I modified that image, Docker image, and then named it with some customizations and so on. You can have any images here. So can we keep it here? Go to this place. I should go to desktop, right? Where is the desktop? I'm in this directory, and after that desktop is not visible. Desktop, yeah. So cd desktop change. Not sure. Okay, so let me do one thing. Let me go to C drive, wd mkdir Rajesh. In C drive, I'm creating Rajesh. Go inside the Rajesh, and inside that, I'm creating one file. So vi pod.yaml. The name of the file can be anything, but content has to be YAML supported. Okay, so paste it. Done. And now the pod is ready. I mean, the code is ready, and now I'm going to do the CRUD for the pod. So what I'm going to do? Qctl create -f pod.yaml. Enter. Did you get a pod? Mind it, it got created in the default namespace. Now it's creating Just wait for a few seconds. Okay, so this is how you can create a pod. See, I mean the down image must be downloading actually. Wait for a few seconds more. Okay, also you can check this. Meanwhile, describe this pod for, you know, pod Rajesh. See, now it started actually. Now if you see that it's running, see pod is running. Look at this. Pod IP address you want O wide. These commands, all this you practice it. I'll give you the notes for it. You can practice it. So this is the pod where Nginx is running. So curl, let me see if firewall is allowing that, or else you'll have to open up a firewall. See, I think it's not allowed. You have to go inside the node to access this one. Okay, so this is the pod which is running your Nginx. Okay, so now I want to edit this. So you want to edit, describe to edit. Again, okay, where is open? We need to locate. Where is this? Where is this? Okay, so let me fix this issue. I remember that it was opening up. I did this. Let me close. Okay, let me modify through UI only. So here you have a pods. Go to the pods here, and this is the pods which I'm talking about. Click on this dot dot dot, and here where is this YAML file? YAML file. This is the UI. Okay, you can modify the UI also, but I'm not suggesting you should go for the command line. Why? Because that way you get a more control of it. So you can modify the UI, but I want you to modify YAML file so you get a control. So here I'm adding the one more uh, labels, and that is called team, and then save it. Done. And now through command line, let me show you qctl describe pod, see, and put the labels. See that? Added. Now I did created a pod, then read the pod, edited the pod, and now finally delete the pod. How do you delete? So you can command line delete pod Rajesh. This is the one of the way you can do that. And now you see that, refresh this guy. See, is gone. See. So how do we create a pod? Are you having idea now? All of you? Hello? Patrick? Guys, are
Yes,
you
Rajesh.
there?
Yeah, getting.
Yes.
Okay. So now what next I want to create? So I want to create this time deployment. So guys, deployment has a multiple feature. So basically one of the feature is you can get many pods. That is the one thing using deployment. So here using the pod, you can get only one pod. But when you use the kind deployment, you can use many pods. That's the one advantage. Second one, whatever the pods you have, you will specify number of pods. Even though someone delete that pod, it will be recreated. The number of pods which you desire will be always actual. So that will be taken care by Kubernetes. If someone delete that pod, let's say you said I needed 10 pod and someone deleted manually one or two pods. So immediately replacement pod will be created automatically. Okay, and then they have a few deployment strategies also, rollout, roll and deployment strategy, rollout, rolling update actually, and few more strategies are there. I mean, recreate update. Two strategies are there, rolling update and recreate. Okay, and you can update, you can upgrade it without a zero downtime. Okay, and then you can downgrade also. So how do we work with it? Deployments. So let me show you that command line for it. So how do we create it? So what you do, go to the Kubernetes deployment DevOps school. Now here I have all the commands actually which will help you to get it done. So there's all the strategies are there. These are the YAML files are there. But I'm not using YAML file now. I'm using command line. So here, this will help you. Look at this. So here, what I'm doing, if you want to create a deployment, you have to use a deployment. So this command will create a deployment. Look at this. So here kubectl create deployment, name of the deployment, this is my image, and from how many replicas, how many pods you want? 3 pods. Let me show you. Now if you see that here, this is I'm doing through command line, you can do through YAML also. Okay, done. Now how many pods you got it? So kubectl get a deploy. See here, deployment has come and get pods. 3 pods should come. See here, deployment. Here it is. Now what I said, let's say my desire was 3. Now you want to delete one. Let me manually delete one, but this time let me do through the UI. So here these are 3 pods. What I will do, I'll delete this one of the pod through UI. Okay, and you can do the force delete, not required in this case. And you see, the moment you deleted, immediately it got created. You saw that? Did you notice? Look at the age here, age 23 seconds, 23 seconds, and 0 seconds. Did you understand that? All of you? Hello?
Yes.
Yeah. So you can work with the deployments. Now you can edit all these things. So see here, you can go and edit here and here, or you can UI also, you can try for editing this one. Click on this my dep, and here many things you can change here. So 3 pods you want, I'm doing through UI actually. 4 pod, 5 pod, see here, 3 running, 1 container creating, let it complete, and then after that again you modify. See 4, new one 5, all these things. So these commands I have given it already. This is called scale. You see here, you can whatever the scale you wanted. Let's say I want 10 pods of it. So let me run this command. 10 replicas. So right now you have 5, you become a 10. What is this? Okay, command line issue actually. This is the right command. And go for 10. See, now you see that, but a 10 and it will be creating the pod. Here it is. See. So deployment is good. Why? Because they have additional functionality where you can get as many pods you want, and also whatever the number of pods you said, it will be maintained by Kubernetes. And some strategies are there. I want to show you through the UI and this one. Go to the deployments, click on this my deployments, and here look at the strategy. So where is that? Config file. Here it is. So now if you look at the strategy, deployment strategy, under can you look at the rolling update somewhere? Here it is. See here, rolling update strategy. So there are two strategies are there. If you see that, gray out, recreate, and rolling update. Okay, so two strategies. And here the current strategies is 25% search, 25% unavailable. What is the meaning? That means the moment you upgrade that pod, 25% of the pod will be down, and then 25% of the pod will be up. So that way zero downtime, and so on. Okay, so this is something which we have to look at it. Now, next service is, which is the most important, it's called service itself. Okay, and this is what? So this is a pod load balancers. This is the pod load balancer. Okay, that means if you want to create a load balancer in Kubernetes, but for what? For pod, then you are going to use this one. So before that, we should understand little bit of it, the conceptual stuff. So let's understand this way. This is your cluster. Okay, this is your cluster. Now in the clustered, you have a two worker, minimum two worker. Okay, just for visualization. Now if you see that here you have a pod running front-end services, and then after that you have a pod running back-end services. Now there is a problem here. There's a two pod of the front end, there's a two pod of the back end. So who will talk to whom? So for that we need a load balancer, of course. So what do? We create one load balancer for backend, let's say. This called service, and then this front end pod talk to this load balancer, and this load balancer send the traffic to this one and this one. So in Kubernetes we call it a service. Mind it, pod load balancing we call it service. But now end user want the access from outside, from the front end, correct? So now we need one more load balancer, this one, and here, and this load balancer will exposed to outside of the world. This load balancer type is called clustered IP type. That means this load balancer only accessible inside a cluster, and this service, this load balancer will be is called node port or load balancer. Two types of you have. If you want to access the through load balancer of AWS, then load balancer, or right now I don't have AWS here, so this one, node. Are you understanding this diagram, all of you? All of you? Hello? 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 I'm audible, right? Or disconnected?
Yes. Yes, Rajesh.
Okay. Okay, so this is the something. So now what we are going to do, I'm going to create a one load balancer which is having the clustered IP. So let me show you that. So here kubectl get SVC. SVC in a shortcut on service. I don't have anything, that the one which you see the service is a built-in in the Kubernetes cluster. Okay, so I'm going to get the service. So kubectl expose, I'm creating service, expose deployment. Okay, I'll just get a command for it. Expose. I forgot the command, to be honest. Let me get this expose -h. So if you do this, you will get the examples. That is more than sufficient. Here it is. Okay, so I will just here deployment. My deployment is my deployment name is mydep. I'm creating a service for all the pods, which is the part of the my deployment. This is the target port where the pod is running. Pod is running on 80 port, I know that. And service port also I want 80 only. That's all. So This is the command to create a service. Screen. See. So now if you see that get SVC, you created a service. Now this is the cluster IP address and this will be accessible only inside a cluster. Mind it. You cannot access outside of the cluster. Okay. So if you see that I'm outside of the cluster, remember that my workstation is set up outside of the cluster. So you cannot connect to this. Okay, service. Okay, so this cluster is accessible inside a cluster only. Now next question is okay, so then I want to access this service from outside, because if you look at this image, I'm outside somewhere and I want to access. So this load balancer I cannot use it because for that you need to be on cloud. This is a AWS load balancer. Okay, this you can use it node port. This is the third type of service. Okay, so what to do? So I'm going to modify the same command and add type. Default is a cluster IP. Type node port and the name of this is NP. Okay, so I'm creating the one more service from the same deployment, but this time with the node port. So I'm going to do clear the screen and enter. Here. You see that one more service you got it here, and this is having the node port running on 30410. So that is the my service. So now if I hit on the my IP address and then port number should be accessible. So let's try. So I don't know localhost will work or not. Let me try. Yes, this working. So this got exposed at my IP address and then port number. So guys, did you understand now? All of you?
Yes.
It's not accessible because it's inside the VM of WSL and also cluster. So this is something which you have to understand. So what we did, how you design. So let's design the whole things. So first thing what you do, you create a namespace. Okay. After that, you deploy. This is your cluster, and you create a namespace, and then you deploy the deployment. Deployment will deploy the multiple pod. Okay. Now, if this pod you want the one internal load balancer, this is called service, then you create a cluster IP service, which I showed you. Now you want that the another service which is accessible from outside the cluster, then this service will be there, cluster IP will be there, but this will be exposed at the node port also outside, and then your end user can connect. So if you see that this service, the one which you see is internal, but this service which you see is external. Why? Because you see here. Now external IP none none none. This is for the load balance type. Three types of, in fact four types: cluster IP, node port, load balancer, external IP. So here this is for load balancer type, which you don't have it because AWS we need to run that command on AWS. If you are a cluster, if you are having cluster on AKS, EKS and all, then you can create that. So now what you have to do? So guys, these are the components. These are the things you need to learn in terms of, let me name it all of this. You have to practice it on compute. These are the one. Storage, DB, DBC, config map, CDS. For security region, for security services, these are the, we are going to do that. One is like service account, roles, role binding, and cluster roles and cluster role binding. The role and cluster role binding. Okay, for utility and all, so you utility general and all jobs, cron jobs. So these are the most popular resources which you need on a daily basis. Okay, so now if you see that UI part, look at this. You see, workload means compute. Workload here they are trying to say compute is a workload. Inside the compute, you see cron job. You can create through UI also, that will be easier. These cron jobs will create a pod, daemons it will create a pod, deployment will create a pod, jobs also create a pod, stateful suite will create a pod will create a pods. Okay, so these are the ways in which you can create a pods. Now, after that pods is created, service discovery. Here you can create a service. Now you see services I created. HPA, automatic auto scaling group, you know, in AWS. That's we in Kubernetes we call it HPA. Okay, and this you know application load balancer. All of you, application load balancer. Hello. So application load balancer in Kubernetes we call it ingress. So service is a network load balancer, mind it. Okay, and application load balancer we call it ingress. Here we have storage. You see PVs. So look at this PVs here. PVs persistent volumes, persistent volume claims, config maps, secrets, and this is the storage class. So these are the 5 things you have to create for your applications, and these are the policies related, network control, and all kind of things, and some of the more services like security. See here, cluster role binding, cluster rules, and rules and rule binding is not there because this is at the namespace level. Networking you have ingress classes, discovery you have it. Some of the cores here you have service account you see here, and core means that was the fundamentally it got introduced initially. Config map, nodes, services, and all, and this is the apps. And all. So these are all the API resources you have to create and start working on it. Any questions so far? Any specific questions you have? Hello.
No questions, Rajesh. Yeah, clear so far.
Okay, so I'll send you some of the important things here. If you go to the LMS, I think none of you are consuming the resources properly. Let me show you some introductions for it. So if you see that, all of you only looking at the recordings, which is available for your sessions. So which is available anyways here. Okay, here, all this session recording. But actually, let's say if you want to master in Kubernetes alone. So what you should do, you should focus on this one, Kubernetes. Click on this Kubernetes courses, mistake, and here is the Kubernetes courses. Now, if you see that here, these are the weekend batches, you can ignore it. Now, this is the crash, you ignore it, and this is the advanced session actually. So in the Kubernetes also, this advanced session. So you have around, you see, 15 sessions, 15 hours of classes. So each and everything has been deep dive. So if you find anything, something which you don't understand or something, so you see deployment, service, cluster management, Kubernetes volumes, pod observability, working the pod demo, namespace, everything. Here installations, and here setting up the master networker. This is where I was stuck. I think you will also install in the Ubuntu, you'll stuck because of it's a Ubuntu problem, not a Kubernetes problem. So you have to fix that registry, repository actually, security stuff. So what is the solution for this? So the solution is very simple. The image which I used it, this one, I have to stop using this image and I get a new image. So AWS should update the new image. I think this was not done last week, so we have to get it done. That. Okay, so spend some time here, and if you have any questions or errors, you can post in the group. I'll help you with that. Okay.
Have any issues with our channel membership, you can drop an email to us at contact@devopschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.